Hello and welcome to this video on antibiotics. What we're going to be talking about in this video is we're going to be talking about what antibiotics are, we're going to be talking about why they're useful, and then we're going to talk about the stages of medicine development. And as part of that, we're going to talk about a little bit of natural selection. So it's quite useful to revise that part of your biology using this scenario. So let's get started on antibiotics. What is the important date about antibiotics? Well, the important date is 1928. Well, why is 1928 so important? Well, this chap here who's just appeared, okay, is called Alexander Fleming. Now, Alexander Fleming did an experiment, and what he did is he got an agar plate. And what he did, so we've got an agar plate, and what he did is he had a lot of bacteria just left growing on this agar plate. Okay, so there is my bacteria. Now, he left this plate for a little bit of time, and then he just came back to it a few weeks later. Now, to his surprise, something else had grown on his plate, just down here. Now, what was even stranger about this is the bacteria that was growing on his plate didn't want to grow anywhere near this mold that essentially grown on his plate. Now, a couple of really useful key terms here. These little dots, because whenever you do an agar plate, you get lots of little dots of bacteria. Okay, they're called colonies. Okay, so these are colonies of bacteria. Now, what there was an absence of these colonies around the mold. So there was no bacteria. So he wondered what this might be producing to stop the bacteria from growing. So this mold was called Penicillium. Okay, that was his name, Penicillium mold. And he discovered that the chemical that it was producing in this little area was called penicillin. Well, I say he discovered it. He called it penicillin. So what this chemical did is it stopped the growth of the bacteria. It stopped them growing. Now, there's a couple of really good things about this. We talk about antibiotics. Antibiotics, as a definition, inhibit the growth or destroy bacteria. Now, there is a really key word here, and it's this one here, bacteria. Now, what that means is the great thing about this is the antibiotics have no effect on human cells. They only affect the bacterial cell processes. So they either stop the bacteria growing or they actually destroy the bacteria. Now, the only downside to this is antibiotics cannot be used to treat viral infections. So in the previous videos, we've talked about cold and flu and HIV, all viral infections, and those will not be affected by antibiotics. So if you get a cold, you shouldn't go to your doctor and ask for antibiotics. They'll have no effect. And in fact, your doctor will turn around to you and say, I'm not going to give you antibiotics. Now, why is that? Well, because one of the things that bacteria can do when they multiply and divide is that they can mutate, and they can mutate resistances towards bacteria. And this is why it's really, really important to continue to develop medicines as we go on. So let's talk a little bit about that. Let's talk about how bacteria get resistant, and then let's talk about how we develop new medicines. Okay, so let's talk a little bit about this antibiotic resistance then. So we've got antibiotic resistance and why it's important to understand. So let's say we've got a bacteria. Okay, here it is. I'm going to use the same colour for my bacteria over there. That bacteria infects a cut. Okay, it's got into a cut and it just starts to multiply. Now, in an ideal scenario, your immune system will come along, okay, it might need a little bit of help from some prescribed antibiotics. But what will happen is over a bit of time, we'll have our antibiotic here, we have our bacteria here. But over time, what will happen is we'll soon be clear of the bacteria. And we're all very happy. Okay? We've no longer got the bacteria in our system, we are healthy, and things have gone well. Now, let's have a think of another scenario. Okay? Here's our bacteria. That bacteria starts to divide. And as it divides, we end up with a mutation. Completely random mutation. But what that random mutation gives is it gives it like a new slime coat, okay, around the outside of the bacteria. So this time, when we put in the antibiotics, here we go. Here's our antibiotics. What we have, here's our bacteria. Here's our mutated bacteria. This is where our natural selection kicks in. Because what's going to happen? What's my next one going to look like? Have a think. Pause the video maybe. Okay, this is what it's going to look like. Here's our antibiotic, still in our system. And there is that bacteria that had that mutation. This bacteria, okay, is what we call antibiotic resistant bacteria. It's resistant to this particular antibiotic. So what we would have to do, and what you'll find would happen, at this point, okay, this isn't necessarily a very good thing, okay, this is a sad thing, because what's going to happen is that bacteria will start to multiply. Oh no, this is not a good thing. We've got another infection on our hands. So what we would have to do is we'd have to introduce another antibiotic. A different one. And here we go. Got our bacteria. But over time, what would hopefully happen is that we would end up with no more bacteria and we'd be clear of the infection. Now, looking at this antibiotic resistance, there's a couple of things to consider. Why might a bacteria have antibiotic resistance? Antibiotics tend to be specific towards certain groups of bacteria. Maybe a certain process, a certain feature of that bacteria, or a group of bacteria. So we've got to have lots of different antibiotics available to treat lots of different bacterial infections. And the other issue comes from this little cycle. If we were to consider this cycle here, there's another option. And the other option is that we go on down here and we continue to build resistance. Now, if that happens, you end up with very, very antibiotic resistant bacteria. And we call them, what we call them is we call them superbugs. So a superbug is essentially a bacteria that has obtained lots and lots of different antibiotic resistances, and we can't treat it. We don't have a drug that can treat that antibiotic. The immune system is going to be fighting it by itself. And often, if you get infected with a superbug, it's very, very difficult to treat and can be fatal. So, where does drug development fit into all of this? So last but by no means least in this video, let's talk about medicine development. Medicine development has a number of different stages. So the first stage in medicine development is known as the preclinical. Now, in the preclinical step, okay, what we're doing is we're identifying, does it have the desired effect? And does it have any side effects? If they're sort of happy with this sort of first step of preclinical trials, what they'll then do is they'll then move on to animal testing. Now, what they're looking at here is you would be looking at testing the drug to see if it had any side effects, and basically with no risk to humans. If the animal testing goes okay and everybody's happy with that, it moves on to the next sort of big step, okay, which is into the clinical step. So this is preclinical, and then it would go into clinical steps. So the first one you would have is you'd have small clinical testing. Now, what does a small clinical test involve? Well, this would involve a small group of healthy humans. And again, they would be answering sort of that initial question of, does it have any side effects? And that's the big focus on some of the clinical trials. Does it have any side effects? If the small clinical trials are okay, it will then go into larger clinical trials. Okay, and what those large clinical trials do is, again, they'll be looking at side effects, which is something that's looked at every single step. Okay, but also this would be looking at the correct dose. How much of the antibiotic or drug or medicine you actually need to give to the person for the desired effect to be had. So just looking at this as well, at every single stage, they'd be looking at side effects, because they want to make sure that the drug that they are potentially going to be prescribing to a large number of people is safe. Okay, so that's everything on antibiotics that we're going to look at in this video. Here's a quick little summary. So what we've talked about is we talked a little bit about the history of antibiotics, talked about Alexander Fleming and his little discovery about penicillin. We talked about what an antibiotic is. Okay, it inhibits the growth or destroys bacteria. It will have no effect on any virus whatsoever. We then did a little bit of revision about natural selection and talked about antibiotic resistance and how that comes about. We also talked about the issue of superbugs in very brief detail. We then talked about how medicines developed in that little cycle of preclinical and clinical trials. So hopefully you've enjoyed this series of videos on health, medicine and disease. I've enjoyed making them. Please, if you've enjoyed them, give the video a like, subscribe to the channel as well. There'll be more videos coming up over the coming weeks. So thank you very much for your support, and as always, I will catch you in the next video. Thank you for watching. As a bonus, here's an outro of my ukulele playing, which I've only just started learning. Catch you in the next video.